Having worked with two kinds of chevrons, a 2-color 2-bead and a 3-color 3-bead, and having explored the idea that the core could start anywhere, the students were then interested to determine if it would be possible to predict the width of the core for any chevron pattern. Each student was asked to create a chevron pattern made up of any number of colors and any size chevron and find the pattern core. For example, how many columns would make up the core for a 3-color 2-bead chevron? Did you focus on the visual pattern, the numeric pattern, or both? How about for a 5-color 3-bead chevron? If you'd like to explore this, pause this video now and using the 7-row template, create a 5-color 3-bead chevron to test your prediction. Can you come up with a generalization to accurately predict the number of columns in the core for any chevron pattern? Here's a 2-color 2-bead chevron, a 3-color 3-bead chevron, and a 3-color 2-bead chevron. How many columns are in the core of each of these patterns? Do you notice a relationship? Based on their experiences, the students generalized to predict the number of columns in the pattern core of any chevron pattern. They found that the width of the core was determined by a multiplicative relationship between the width of the chevron and the number of colors. To test this theory, they created a 3-bead 5-color chevron that they accurately predicted would have a core of 15 columns. Students also discovered that their theory worked for the diagonal pattern as well, because when the top 3 rows of a 7-row diagonal pattern are reflected vertically, or flipped, the diagonal pattern becomes a chevron pattern.